So, hello everyone. My name is Indrajit, and I am currently doing a research in CellStrat. So, as part of CellStrat, I mostly work on NLP techniques and on textual data mostly. And so we basically work on multiple um, algorithms and POCs based on the research papers that are publishing in the recent times. So in this session, I will be discussing one of the POCs or models that we have built from the recent papers with Bert and Albert. So we'll be discussing in detail about the architecture and how it has been built and what algorithm has been used. Okay, so I'll go ahead with the session. So that's the agenda of the complete session. So to begin with, I mean, to make it more interesting, so I just would like to quickly tell about a chatbot that has been developed in 1960s, which was very interesting, and it used to be very I mean very good responsive in nature in terms of the complex queries that has been asked to the system, right? So if you see a quick conversation, so I asked to the chatbot that, hey buddy, this is Indrajit, and it says it is nice to be chatting with you, and I said, great, nice chatting with you too. And then it responds, we were discussing you, not me. So I say, oh, I see. And then says, okay, great, nice chatting with me too, tell me more. And when I say, are you kidding me, and says, would you prefer if I were not kidding you? So there's of course a rule-based system, and it works based on what queries that you ask. But however, it's more of it does the job, and it's really good at that time. Now we see a lot of implementation with chatbot and question answering systems, but to understand a QA system, we need to know that they are completely different models and architectures. They are different from each other. Although the nature, the way we get responses from the system are similar, but their architecture and the way they build are different. I mean, it's of course based on the use case and the application. So Elisa was one of the chatbot that has been developed that times. Okay, so to go ahead, so what is a QS system? So there's a huge misconception by a lot of people that they think that chatbots and QS systems are same or similar, but in actual they are completely different approaches or methods, right? And algorithms and models, except the input and output, which is in text. So given out a human language question and giving a proper answer for it is the purpose of building a QA system. So the aim of a QA system is to, I think audio is working fine. So as I was saying, so the aim of the QA system is to provide short and correct answers to the user, saving their navigation time. So the QA system is different from a Google search engine, right? Probably you can call it as an information retrieval system, where we provide certain queries and we get a set of relevant documents. So the documents are retrieved based on their rank or the number, right? That's the highest rank of the document. So, but in QAs, we do not do that. We actually work on the the paragraph or the phrase that we provide, and the answers are given from that particular phrase, right? So let's go ahead and we'll see more into that. So there's a quick overview of QA systems that has been built in 1977, 1998, and and 78. So there are two different types of QA systems that were available. Like if you see here, this Lunar that has been developed in 1977, and they were really good. I mean, the type of queries that has been asked to the system was really complex so in nature. So if you think for an example, right? So a lunar samples with magnitude. So when it asks, give me all the lunar samples with magnetite. So it has to go to the system, it has to calculate all the available samples, and based on that it gives you an output from the system. So basically you need a lot of calculation, a lot of grammar for understanding the query and process it and reply to that, right? So that was pretty good at that time in terms of a question answering system. But however, they never used, I mean, there were no models such as recent neural network models or deep learning models or even machine learning models, right? So these are all based on completely rule-based systems. So the challenges with the QA system of any time, so if you think about that, is the knowledge base, right? So given the current state of the art, a knowledge base can be broad or deep, but not both. We cannot have a subject wise, or you cannot, I mean, you can only build a particular subject wise, or you can broad the area for multiple subjects, but you cannot go deeper, right? So as a thought process, I mean, if we when we think about a system that can be built, so it we have to go either way, right? So and it's basically a very critical trade-off between the breadth and the you know and the horizon, right? So in domain specific knowledge is based like optimizing the depth, right? So decisions about where to emphasize breadth versus depth are critical trade-offs, right, in this design of QA system. So to divide QA systems approaches, we actually have the primarily we can have a question classification, then we retrieve the information from the documents, and we provide answer, basically the answer extraction from the documents that has been retrieved. So first we need to understand the type of queries that has been asked to the QA system, right? Okay, so a QA system can be divided into four categories primarily: closed domain QS, open domain QS, rule-based QS, and web-based QS. So in this session, we'll mostly discuss about open domain QS and closed domain QS a little bit, but mostly into the open domain QS system. Okay, so a closed domain QS is in the primary purpose is to is to um, it basically built for internal purpose and not available to the world, right? So when we talk about closed domain, and it uses a modern search technologies to find information in your own documents. It also allows anyone to ask a question in natural language and get an answer without having to read the internal document. So I have a complete document, let's say 2 or 3 page document, and I have to go through the complete document. Instead of going through the document, let's feed that complete document to the system, and based on the document, whatever queries I'm going to ask, it is going to answer me. So it saves a lot of time, and it also been very precise of what queries that has been asked. Okay, so to make internal search experience faster and more natural, that is also one of the purpose of building a closed domain QoS. So there is some noise in the backend. Can someone mute? Okay, thanks. So open domain QoS, so as the name relies, it tells that question and answering can be an open-ended and can be nearly any kind of domain or topics, right? So thus the QoS system finds the answer out of the help with the information retrieval, computational linguistics, and knowledge representation of the data for finding those answers for the questions given. So a QA system takes the natural language question as an input and then the group of keywords. These systems aims at returning an answer in response to users' questions. So basically, a open domain QS is very broad in nature, and it can be from any topic, any domain, so that can be applied for I mean, as we think logically, so that's the purpose of having a open domain QS. Now if we think about let's say a 10 standard class, and I'm I want to get the answers for only a particular subject, let's say mathematics or chemistry. So that can be a closed domain QA system, right? Again, when I think about a complete class or entire education system, it can be an open domain QS, right? So um, to know a basic understanding, basic idea of how these works, the flow of QoS is first basically in a Wikipedia or any document reader, we retrieve the documents, right? How many or the questions from Wikipedia is how many Warsaw in inhabitants or spoke police in 1933. So the documents has been retrieved based on the query that I have, and it reads from that, and on top of that you apply certain model or algorithm which gives you the output or the answer, right? So to be in today's session, I do not want to elaborate on more of a particular model, but I mean we will discuss about BERT here, but there are multiple models that are very much popular in recent time with building question answering models. So if you see in the papers that has been published recently for focusing on solving question answering problem, these are the four models which are very popular and are on the top rank in Squad or any other database of NLP. So QANet and question answer net that has been published in April 2018, and which claims that it's really fast and it's good at answering, giving answers to considering any Squad data set. Let's say as we are here we are using Squad data set, we'll look into that. So QNet is very good in responding to queries. There are certain limitations and advantages, disadvantages, but however, in comparison to BiDAF, QNet proposes that they are able to
Hi,
solve a lot.
Indrajit. Indrajit.
Yeah.
So seems the slides are not moving for some reason. Not sure why is that. We are seeing
So
your screen, but the slides are not moving.
which slide we are now? Okay, I'm sorry. So I think I mean as I was discussing about. So there are so many um, models that are in the market, but a focused one which are basically built for QAS and which are claims to be working very well for solving question answering model, question answering solutions. So the QNet, BiDAF, BERT, and ALBERT recently published in October 2019, which is to be very accurate in giving the answers, right? So we'll talk about these models in a quick overview and how they are built, but they are basically similar in nature. There is a difference in the way we provide or we add attention to the system or to the model. That way it is different. So again, if you compare BiDAF and QNet, right? So we have C2Q, I mean question to context and context to question. So these are basically applied based on the attention that we give, right? So QnA is a little bit better in terms of BiDAF. So I would suggest to go through all these papers to get more idea about what exactly has been implemented in this. So you can actually think about a combination or combined model, or probably which is far better than only using ALBERT or BERT, right? So that would be one of the approaches anyway. So I will go ahead with the next slides. So to go deeper into the architecture, right? So first and foremost, the thing that for any question answering model or any of the systems, we need to understand what is encoder and decoder architecture, right? So what it does is mostly when you feed into a single sentence or any word, so it the encoder architecture network, it actually converts them to a context vector CI, right? If you see, so then the decoder feeds that context vector and gives you the output. To in a layman term, you give a input and it converts to a single context vector and gives you the output from a decoder, right? So what happens if we are using these models, right? Any of these QnA, BiDev, BERT, and ALBERT, all of these models uses these nature, this architecture internally, but there are certain changes the way encoder is feeding the output to the decoder, right? So if you think about, if you know about RNN, so RNN uses the same technique where we feed the previous input, the input from the previous layer to the next layer, right? A hidden state has been hidden state, and the weight that actually passes to the next layer. So similarly, in attention, what we do is, so in attention we have these particular kind of network where we get each layer output as, let's say, a1, a12, a1tx, and the I have, let's say, a tx number of hidden states. So I will get all the outputs from these states, and I will put that feed that one to my network, so that to the decoder network, right? So the attention is basically given the highest weightage out of those um, uh, weightage that I'm getting from the previous layer, right? So that is being feeded into the next layer. So that's what you see here. The C1 is being feeded, and then C2 and CT until, so I go till every network is fed with those the complete set of the weights that I am getting. So the highest weighted word, let's say if I have how are you, and I have to give attention to R or U, or probably if I have somebody's name, and name should be given more attention, so that will be given more I mean will be having more probability value, so that will be passed to the decoder network, right? So I would suggest a very well designed and with very well explained with the memory and how the attention is given in basically in terms of computer memory and graphics. This is a very nice paper, augmented RNNs. You can go through that, where it demonstrated how actually attention works in terms of memory and vector representation. So to go ahead, right? So normally LSTMs have this attention mechanism of, I mean, on top of LSTM, we can use attention, right? So LSTM can be one directional, let's say from encoder to decoder. So again, if I feed something from decoder to encoder, it can be bidirectional, right? So the same way, if I feed the values coming from decoder, I can feed back to the encoder, so when it goes to bidirectional. So if you see here pi, right? So it's a bidirectional LSTM. So so normally you feed into the bidirectional LSTM and you get the output. But if we apply attention on top of bidirectional LSTM, so I have a LSTM which is bidirectional. On top of that, I have an attention mechanism applied. So attention is giving more weightage to a particular word. So let's say if you read these the query that I am feeding into the network, who did Genghis Khan unite before he began conquering the rest of Eurasia, right? So this is the question. Now I have a paragraph. From this paragraph, I need to find the answer. The questions are, it can be anything but based on the paragraph, right? So I'm asking a particular question. So the paragraph is, he came to power by uniting many of the nomadic tribes of Northeast Asia. So if you see here the Genghis Khan, right, the red color, so it says Genghis Khan, he started the Mongol invasion that resulted in conquest of most of Eurasia, right? So the question is, who did Genghis Khan unite before he began conquering? So the paragraphs are, it's very simple that the network focuses in that those sentences uh, which are which are basically based on the query that I'm asking, right? So Genghis Khan is one of the word that has to be given primary attention here. So it starts the prediction based on that, and it applies a softmax on top of the query and the weight that is given, right? So this is a normal Stanford attentive reader. I mean, I'm not yet gone to the BERT model, but this is how each, I mean, any of the, a network that has been working. So it actually to demonstrate how attention works and how attention is, applied to any of the RNN or LSTM models. Okay. So I mean, there are multiple ways to add attention to network. So if you see here, this is one another example where I have multiple LSTMs. So LSTM1, if you see a first layer, I have another layer of bidirectional LSTM. On top of that, I'm getting the weighted sum, right? And those are going as a query. So on the left side, whatever you see in the architecture, and on the right side, I have another LSTM layer where after applying glue and all these things, whatever value I'm getting, I'm feeding those to the LSTM, which gives me the paragraphs P1, P2, and P3, right? And I find the similarity score based on these question and paragraph, and it gives me the output, right? So if you see the difference, we find the loss between the query and the passage that has been asked. So it is, I mean, to understand these are the basic ways of feeding into the network, that question and a paragraph, and my goal is to get the answer from the network, right? So how does it know that from where the answer belongs to, right? So when the question is asked, let's say Genghis Khan, right? So it should focus, or it should point to from the paragraph from where the question is coming, right? So that way the network focuses on that particular word, and it only retrieves those sentences which are relevant to the query, right? So how attention and the similarity mechanism works, I mean, if you know about the cosine similarity, so a question is, let's say, a axis in the vector space, and another paragraph is another axis in the vector space. So if we have to minimize the angle between them, it has to be similar to them, right? Similar to the query. So the question asked, it should be similar to the paragraph or where it is matching, right? So that way we get the exact sentence from the document. So finding the similarity between two documents, or let's say question and paragraph, right? Those also considered as two different documents. Okay, so to go ahead, let's say a simple BiDAF architecture. How does it look, right? If you understood by now, how is a attention layer and what is attention flow and how it works, and embedding layer and word embedding system. So if you see a quick look of this particular paper, it has a context and a query, right? So if you see on the below, so there is a context that has been given attention. So it goes for context to query and query to context, right? So that is given attention here. Along with that, q1 and q till qj, I am feeding into the query along with the context that is given to the layer, right? So these attention goes to the network, the LSTM network, and it gives me uh, output, right? So the output is basically applied with softmax, and it gives you the query to context output, right? So here the difference is, I mean, in the other networks we do not have a query to context or context to query kind of mechanism, right? So based on these, we get the answers. Now in BiDAF, right? So there are variants of and improvements to BiDAF architecture over the years, but the central idea is the attention flow layer. So if you see here, the attention flow layer uh, on the left side, right? So the block shows where the attention flow layer works, right? So that's the main area that is to be focused, which is based on query to context and context to query. So a context is given, based on that a query is fed to the system, and the attention is applied on top of that. So attention should flow both ways, from the context to the question and from question to the context. So make
Excuse
similarity
me,
matrix. Yeah,
Indrajit, one question. What is the accuracy level in terms of percentage of the QAS? Which model delivers highest level of accuracy?
I will come to that. So I have the slides at the end. So let's
Sure.
wait for that then. Yeah. Okay. Thanks. So make similarity matrix with W of dimension, right? So if you see here, basically C to Q and Q to C, context to question attention, which query words are most relevant to each context word. Now I'll go ahead with these. I mean, you can actually go through these paper in detail with the BIDEF or whichever. I mean, is interesting, because you will be able to see most of these papers are working on the same principle. There are a few changes in the architecture which probably suits more with the type of data set that we are going to train on. So the training time and the accuracy, both are the primary measures for choosing any particular model. So recent more advanced architectures are like BERT and all. I mean, if you think about a QnA model, there are certain mechanisms like CoAttention, right? So CoAttention, apart from like context to query, this is little bit different in adding the attention layer. So if you see a document and a question, right, two vectors that I'm providing, I mean adding a CoAttention encoder in that, and that gives me um, the output here. So if you see quickly a quick overview of this, so there's a D and Q on the left side. So a document that has been fed to the network, and along with the Q to the networks, and it forms a matrix, right? And a vector AQ and AD, if you see, so that I have a product of those two matrices, and it concatenates and gives me another matrix, which is again fed with the document. So it brings a co-attention mechanism on top of the network, right? And then I actually feed into that to the bidirectional LSTM system, right? So this way also it can be done. Now to come to the model that I have trained on, this is mostly on the BERT. So in the BERT has been actually published in I mean, in 2018, but the recent one with Ailbert, right? So, and a lot of improvements that has been done in 2019. So, if you see in the model that I have shown, so you can see the paper for Bert and Ailbert both. Okay, so it's the transformer architecture. I mean, in used in Bert, right, is a sort of attention on steroids. I mean, more or later. So, this is basically a very complex architecture in terms of if you compare with the other architectures like QNet or BiDef, right? So here it uses a transformer architecture to give you the output for a particular um, input, right? So normally a BERT architecture looks like this. So if you base architecture, it is a lot of encoder layers that is in the transformer network. So we can add multiple encoder networks on top of the system, and that is up to you how you are going to. I mean, this is a kind of a hyperparameter that can be added based on your requirement, right? So normally with BERT, Elmo, and OpenAI GPT, if you see I mean, a pure BERT architecture looks like this, where I have the encoder input, right? So I have multiple encoders input to the transformer, and it gives me the T1, T2, or Tn outputs, right? From that. Now, a multi-level inter-attention that is applied to a BERT system, right? So the inter-attention on top of the the model is the most important thing that we should be focusing on, and that's where the actual advantage of BERT comes in terms of the other models that has been built, right? So as you were asking about the accuracy, right? So and the top models, so in Squad 2.0 leaderboard, we I mean in terms of human performance, if you see the F1 score for human performance is 89.452, and comparing with Albert, right, plus DAF and verifier ensemble model, it works with 92.425 F1 score with a right. So this is basically far better than if you I mean I have only taken the top 4 or 5 models, but there are BiDef or QNet, those are also given in the Squad dataset, Squad website. So those are which are far better performing in nature. So Albert is, as it is very light uh, BERT model, it actually outperforms the other models, right? So that is one of the advantage with Albert. But however, BERT is also fairly good, which we have trained so far. We did not try with Albert, which seems to be also I mean as per Squad dataset is very high in accuracy. Okay, so that's all. I mean, I would like to quickly share a quick demo of the system, that how this model is works, and a quick code review of the BERT model. So let me share the screen quickly. Should like to. Meanwhile, you can ask any questions that you have. So can answer those.
One question is, what is the future scope of QoS adoption by enterprises? Key statistics will help if there is any.
So there are a lot of areas that are emerging with the NLP and with advancement of the BERT architecture. So which is going to really help in solving a lot of complex issues in different organizations. Um, for example, let's say on the education sector, or even we have done it for automotive industry, where a particular system which is newly launched, and let's say engineers have no idea about how the model works, and what actually the structure is, what is the component, how much frequency it works, and what is the horsepower. Let's say these kind of queries which are very need to go through the manual, need to read the complete document, which is a cumbersome job. And probably in some industries where the instruments or the machines are changing every month or quarter, right? So it's very difficult to cope up with those. We can probably have a system or model like this, which will help to solve their day-to-day challenges with these kind of queries or questions. So I believe this is really revolutionary. I mean, people or organizations, if they think of the challenges and in documents reading and multiple textual information that's every day getting published, so those are really solvable in using QA system.
Okay.
All right, so I will be sharing the screen. Let me know if you are able to see.
You have to, yeah. Uh,
So here, so it's, if you see here, I context, right, a question that has been given, and conversion clause are often found in ARM contracts. So this feature allows you to convert the ARM to fixed rate mortgage or at a designated time. So this is a particular paragraph, right? So as I was talking about a paragraph that we have to feed into the network, and we feed in a question to the network. So based on that, it gives me the output, right? So if you read here, the terms and the conditions vary from lender to lender. Generally, though, you must give your lender 30 days notice before converting. You must also pay a fee, usually $250 to $500. So this is the answer is lies in this particular paragraph. Now my question is, what is the fee associated with a conversion clause, right? So it should give me $250 to $500, right? So um, let's test this question quickly. So if we have a query something like this, feed it into a network, and I want to ask, let's say I'll copy this question. We can have any kind of paragraph, um, you know, asking to the network. Based on the paragraph, it will give you the answer, right? So this is what we get from the QA system. So that's giving me the output as 250 or $500, right? So this is the data set that has been trained with a Squad 2.0. With any output that we can try with an Wikipedia document. So that also will work, but that is not exactly trained on that particular document, but it will try to, it gives a fair amount of correct answers. So let's say we'll talk about deep learning architecture, right? So let's say get a wiki page, and I will take something from here. So deep learning architecture such as deep neural networks, surface network was very inspired by information processing and distributed communication nodes, right? So let's say take this, and I will put that as a paragraph here, right? So I will be asking, let's say, some question like, um, so artificial neural networks, right, were inspired by information processing and distributed communication. So what is ANN is inspired from? Let's see. So if you see here, right, information processing and distributed communication nodes and biological systems, right? So inspired by information processing and distributed communication nodes and biological systems, right? So this is a fair amount of correct answer that we get, right? And which is really very good output that we can get from this particular system. Okay, so that's all from the demo side. I'll take the questions now, and you can answer to any of the queries. Okay.
So one question from me, Indrajit. How long form answers can be given by the system? Is it only for short questions and answers, or for long form answers are also possible?
We can increase the span. So there is a way that we in the code we can increase the span so that answers can be very long as well. But as the answers are from the sentences, right, so or paragraph, so the answers or QA system is actually primarily, the focus is to get a crisp and short answers. So we do not expect the system to respond with a very long answer, but we, this is like a span is given with 20, let's say I can increase it to 40 or 50.
So is it characters or words?
It is the words, I guess, is the word.
Okay, because I'm talking from education context, so a lot of education systems are being built. So if we can put in QnA system there, so students or professors will be able to know exact answer in long form if it is possible.
Yeah, I mean, so it cannot be again another document responding, replying, giving answer with another document, but it
Okay,
can be, 2 or 3 sentences or 4 sentences max. We can do that. I mean, that doesn't actually solve the real purpose of these Q&A.
sure. Okay.
Yeah.
So audience, any other questions you have? So there was one question. Mm, Please suggest some other practical applications of QA system. What human problems can be solved using this system? So I have already given example of education, and you have given example of Wikipedia. Any real application areas you know, Indrajit, where it is being deployed across the world or being tested by companies?
Um, Okay, so I mean, so far I'm not sure that if any of the organizations is really using QoS, but it can be a really fast and good search engine for any organization they want to build in, right? So let's say on top of these, I can have an information retrieval system which retrieves all the documents in the web or in my corpora, and the documents are retrieved from the web. Based on that, now the QA is system, it fires a query to the information retrieval, so it goes to the exact um, document where that paragraph or the word that's exactly matching, right? So it gives you the output from those documents. So only the relevant documents. I do not need to worry about the documents that is being retrieved by IR, but I will only see the output that gives me the answer from those documents, right? So as a search query, I mean, as a search engine, this is really going to solve a lot of problems in terms of that. uh, that is one area. Other area that I actually thought of, I mean, there are a few organizations, I think, I'm not sure in India, but outside that they are solving problems for, let's say, turbine, or the problems of particular giant machines. So they actually deploy those machines, but now, the challenges are there with the engineers that they do not exactly know how this system works. I mean, when they start learning, there are a lot of trainings, and after that, they actually, get into a lot of issues. So the
Mhm,
issues are coming in every day. Let's say this particular function is not working, and they need to contact the vendor, and there are a lot of, communications goes on. So
mhm,
if we have a system, or a knowledge base, instead of that is going on every day. Let's say I have a particular issue, then I have logged in to the system that, okay, this is what happened, and based on that, this is what I have solved, right? A problem
mhm,
and a solution. So now
mhm.
another engineer comes, he doesn't need to actually rely on his senior associate, or senior manager, that how what to do now. He can probably have this kind of QA system where he can ask, okay, this particular part is not working, what shall I do? So these are actually a very real-time applications that can be used for QAs, I believe.
So possibly I can say what comes to my mind is you can remove all user manuals that come with any device for that matter. Am I correct?
Definitely, yeah, yeah.
Okay, that's a very good use case. Okay, another is which service is embedded to fetch or search the answers or text from wiki? Is it QA search engine service or something else?
From wiki.
Yeah.
I didn't get the question. So is it based on this QA system he's asking, or in general?
So in general, I think which service is embedded to fetch or search the answers or text from wiki?
So from
Uh,
wiki, see, from wiki, here, I mean, in this system, we just feed it in the paragraph, but wiki documents are basically retrieved from web, right? So when we search something, it actually goes as an information retrieval system. If you think about the rank of the documents, right? So the highest rank is given based on the search query that has been given. So the complete it is also in the same mechanism, a query to cosine similarity, and the highest rank is given which is more similar or more closer to the documents. So in a search engine, when we search something, it only retrieves those documents which are more similar or closer to the query. But here in the search engine, we do not have a attention mechanism, or it knows or give more higher attention to a particular word. I mean, these neural models are actually completely different in nature and the way they work or retrieve the documents or a particular sentence or word, right?
Next is, can it be integrated with chatbot?
Yes, we can integrate with chatbot. Chatbot is uh, basically a sort, and I mean, those are meant for giving you a very simple questions, like for example, Domino's, right? So I have to book a pizza. So where to look for, and what time I will get, and what are the options available. But it if you really want to make it more vast in nature of responding those queries, but it really doesn't, again, you know uh, uh, just be a chatbot. Then it can be it becomes a QA system where you actually expect all kind of queries related to Domino's or pizza should be answered, right? So chatbots are basically a very small version or application of what QAS does. The architecture and everything that has been built so far with the chatbots are not with deep learning, and they don't need a deep learning architecture, because when you can solve a particular issue with you know a small car, you don't need a truck basically. So I think that's one of the thing.
Okay.
Yeah.
Uh, does it require dedicated repository for paragraph?
Dedicated repository, you can
For
have a
paragraph.
dedicated repository. You can have, as I said, instead of a paragraph, I can have a complete web. I'll be pulling all the documents from web. I can restore somewhere in the repository, and only I will pull those documents and the paragraphs from those documents based on the query that has been asked, right? So it can be again a repository as well. No problem with that. I mean that the complete system architecture is actually a thought, and a lot of understanding requires that how you want to build it and how fast it should be and what kind of system or database or organization we are building it.
Okay. So you are saying that in a sense, if you have repository, it will be faster, or if you don't have, then it may take some time, maybe few
So let's
more
say
seconds.
where there are so many users, right? Let's say like Amazon DynamoDB. If you are using a DynamoDB, which can handle 10 million queries at single time, right? In a second. Sorry, in a second, I guess. So
Mhm.
that's up to the application that person looking for. I mean, and cost and other trade-offs are comes into picture. But normally, if we have, let's say, 1,000 documents or 10,000 or 20,000 documents, this is fair enough, and we don't need to store them in the repository. It should work fine.
Okay. So he is rephrasing the question, I think. So so yes, this webinar is being recorded. We'll be putting it on our CellStrat YouTube channel. I'll just put the address for the same here for everybody to note. So I just shared the CellStrat YouTube channel link. You can note it down and see all our previous as well as this webinar and future ones. Uh, so he has rephrased the question. It says, in enterprise there are policy documents which employees are querying. So
Okay.
uh, will it require database or PDF or HTML? What will work?
Sorry, can you rephrase the question?
So in a company environment, there are a lot of policy documents like HR or finance and other things. So employees are querying them all the time. So will it require a database or a PDF documentation or HTML? How will it inquire from that database? What kind of database would be required?
Okay, okay. So if the information is stored on the database, right, we can actually retrieve them based on I mean, not a direct query cannot be done that. So probably we can have a cache mechanism or something where we only store those documents that as actually, relevant to those. I mean, basically those data sets from the database. So a particular uh, we need to have a query model on top of the database, which will give me the set of data sets, or the values um, based on the query that I'm asking. So I believe that will be a little complex in considering the time that is taking, or giving the output, but it can be done with, I mean, I we need to think about how that can be solved. So but it is possible only if we have a query model on top of the database to feed into the QA network. Because there is a, I mean, if you are directly querying, there is no way we can process the documents, or the paragraphs. Because let's say if some query has been asked from a particular uh, um, which belongs to a particular table, let's say employee, right? I cannot have or that information is not available only in employee. So the query mechanism should be something that it gives me, or it forms a paragraph from all these tables which are related to the query that I'm asking, right? So it gives me the document. Based on that, I can retrieve that particular information. So which is again another problem in itself to solve before we actually linked into this.
Yeah, I hope it solves the query.
Yeah.
So, but in my case of user manual, can it be stored in
Yeah.
PDF format?
With PDF or user manual, it's where it's very useful. I mean, we can work on, right? With PDF or user manual, the only thing is we need to do is we have a OCR or something that read the image, or the PDF document
Okay,
by with any document reader, and put it to a repository and read it from there. We can do
okay,
that as well. Yeah.
right. Any other questions, audience? I think most of the queries have been resolved here. So we are very much on time, and I don't see any other queries coming in. So we have almost everyday webinars going on now, and this webinar is being recorded, will be posted on YouTube channel in about 3-4 days time. So you can go back and listen to it again. And of course, Indrajit will be giving us a lot more presentations in future. Uh, so people are
Sure.
appreciating. No questions. Thanks for very good presentation. And
Sure. Thank you, Vishal. I will, if you have any queries, you can, I mean, you can post it here as well, or you can contact me for any, further information you need. Thanks. Thank you for attending.
great. Thank you all, and have a good day, and good day to all across the world.